students, welcome to Narayan PU College online classes. So in the last video, we have discussed about the chlorine and hydrogen chloride, and today we will discuss about the oxoacids of halogens. Let me put the heading oxoacids of halogens. Oxyacids of halogens. So mainly here, halogens form four types of oxyacids. The first one is hypochlorous acid, halous acid, halic acid, and perhalic acid. Clear? So one by one we will discuss. First I will give table and which halogen forms which type of oxyacids, and after that we will discuss. Clear? So first of all, and in this case, right here oxyacid, and here what it is one here? Fluorine, chlorine, bromine, iodine. Clear? So the first oxyacid here, I already mentioned four types of oxyacids, and first oxyacid here is hypochlorous acid. Hypochlorous acid, or we can write halic acid. Halic 1 acid means what it is? The halogen oxidation state in that oxoacid is 1. That we will call halic 1 acid. That can also be called as a hypochlorous acid. Clear? And the second one, what is the second one I mentioned here? Second one is halous acid. What it is not here? Halous acid. Or we can write here halic 2 acid, means that the halogen oxidation state in this, in this halous acid is +2. And in the same way, third one. What is the third one here? Halic acid. Simply this is halic acid. Or we can write here, halic, 3 acid, halic 5 acid. Clear here? So HCl O3, if you write halic 5 acid. Clear? And the last one is perhalic acid. And the last one here is perhalic acid. Or we can write here halic 7 acid. Means oxidation state is what it is here. This is. So how many types of oxyacids halogens one can form? Mainly 4 types: hypochlorous acid, halous acid, halic acid, and perhalic acid. If suppose iodine is there, periodic acid, chlorine is there, perchloric acid, like that. Clear? So in this one, this is acids. So first one, fluorine. Fluorine forms only hypochlorous acid. Means this is HOF. Hypochlorous acid. What it is here? Hypochlorous acid. Only one acid, because being a high electronegative and the small size of fluorine forms only one oxoacid, and that is hypochlorous acid. Clear? And chlorine can form all acids here. What it is here? Hypochlorous acid. Chlorine is there. Halous means chlorine is there. Hypochlorous acid. Clear? And it can also form, and hypochlorous acid, HClO2, can also be written. This one is HOClO, can also be written. OH is there here and C-double-O2. Clear? So this is chlorous acid. And the second one is chloric acid. This can also be written as HClO3, the formula, or you can write here HOClO2. Clear? So one OH means OH will be present here. Clear? And perchloric acid, HClO4, or can be written as HOClO3. This is perchloric acid. Clear? So this is about which one here? Clear? This is about the chlorine. Clear? So next one, bromine and here iodine. Bromine forms hypochlorous acid and this it won't form the Halogens acid, it forms but it is unstable. And next one is HBrO3, R can be written as bromic acid, and HOBrO2, and last one here HBrO4, R can be written as HOBrO2. Clear? And last one, iodine. So iodine, same, it will form the hypochlorous acid, and iodic acid HiO3, R can be written as OHIO2, and periodic acid HiO4, R can be written as here OHIO. So these are about what is oxalic acid. First one here, oxalic acid, table like neutral. Clear here? So this is what it is here, acids, oxalic acids here. So hypochlorous acid, if you calculate the oxidation state here, OH, hypochlorous acid. Hypochlorous means this is O, and here fluorine is there. Fluorine is attached to some oxygen, and oxygen and fluorine, which one is highly electronegative? Fluorine. So that's why fluorine, it takes the electrons towards it. So oxygen is losing electron and fluorine is gaining electron. So that's why oxygen, what it is here, -1. So that's why here oxidation state how much here, +1. Simple. This is HOF. X you can assume, and this is -2 and this is +1. So what is the X? X plus 1 minus 2 is equal to 0, x minus 1 is equal to 0, x is equal to 1. Hypochlorous, what is the halogen oxidation state here? +1. So in the same way, if you calculate, and the hypo means hypochlorous we have calculated, halogen acid you calculate. What is the oxidation state here? And it is -2, it is a +1, so it is a x. Clear? 1 plus x minus 4 is equal to 0. X is equal to what it is? 3 oxidation state. So it is here 3, not 2. Here what it is here, oxidation state is 3. Clear? And the next one, HClO3 you take. O3 means what it is? -2. Same. 1 plus x minus 6 is equal to 0. X minus 5 is equal to 0. X is equal to 5. So what is the HClO3 if I take? What is the oxidation state? +5. If I take HClO4, and what you will get here? 4 into 2, 8, and here 7, and what you will get here? 7. This is oxidation state 1, 3, 5, 7 oxidation states. Clear? So this is about what it is here, and next we will discuss about the structures of oxo acids. Clear? So we have discussed about the oxo acids. You know that halogens forms mainly 4 types of oxyacids: hypochlorous, halous, halic, and perhalic acids. Clear? So hypochlorous, what is the halogen oxidation state? +1, and in hypochlorous +1, halous it is +3, halic acid oxidation state of halogens is +5, and perhalic acid the halogen oxidation state is +7. Clear? Now we have to discuss about the structure of these oxo acids. Clear? So and I will first discuss the structures of oxo acids of chlorine. Means what is the structure of oxo acids of chlorine, and the same structures will be for the fluorine, bromine, and iodine also. So that's why I will discuss only here oxo acids of structures of oxo acids of chlorine. Clear? So the first one here is hypochlorous acid. Hypochlorous acid. What is the formula of hypochlorous acid here? Hypochlorous acid is this is OH here. Clear? You know that chlorine is forming only one bond with the OH. Means what is the chlorine electronic configuration here? 3s2 3p3. What it is here? 3s2 3p3. Yeah. So you know that, and we have 3p5, so that's why this is 3s2 and this is what it is 3p5. 1, 2, 3, 4 and 5. This is chlorine, valency electronic configuration. So that's why here 1 unpaired electron is there. That 1 unpaired electron is used to make the bond with the oxygen. Clear? So that's why. And remaining how many lone pairs are there with the chlorine? Chlorine having 3 lone pairs. So that's why. And if you see in this one, there will be a 1 bond pair and Remaining how many lone pairs will be there here? 3 lone pairs with the hypochlorous acid. So that's why you see what is the structure of this molecule, and you know in this one chlorine is having one bond pair and how many lone pairs here? There are 3 lone pairs. Total how much more? 4. 4 means what is the hybridization here? sp3 hybridization. The chlorine hybridization in the hypochlorous acid is sp3. You know that if one bond pairs and 3 lone pairs, what is the shape of the molecule? Linear. Whenever lone pairs are greater than bond pairs, you will get the linear shape only. Clear ma? So what is the structure of this molecule is, I will write here, this is a chlorine linear, this is OH. Clear ma? So now you know 3 lone pair of electrons will be there. This is the structure of what is here, hypochlorous acid. Clear? What is the oxidation state here? Oxidation state is +1. Chlorine oxidation state how much more? +1. So next one here is chlorous acid. What is the acid here? Chlorous acid. Clear? What is the structure of chlorous acid? You see now, and this is the central atom chlorine. And you know whenever oxyacids, when we write for the non-metals, means if you write for the chlorine or sulfur or whatever it may be, nitrogen we have discussed, first you have to write here what it is, OH should be attached, and if more oxygens are there, then there will be a one double bond O. Clear? So this is the, you know what it is, chlorine, this is hypochlorous acid. What is the formula of hypochlorous acid? HClO2. One oxygen is attached to the chlorine with the OH, another oxygen is with the double bond. Clear? So now chlorine should have how many? So chlorine is forming how many bonds here? 3 bonds. When chlorine is forming 3 bonds, and it will have the 2 lone pair of electrons. Clear? So that's why, and here, and there are 3 lone pair of electrons. There are how many lone pair of electrons? For 3 lone pair. What is the hybridization of chlorine here? Chlorine hybridization is how many bond pairs are there? 1 and 2. 5 bond we never consider. 2 bond pairs. And how many lone pairs now? 2 lone pairs. Then what is the shape here? What is the hybridization? sp3, 2 plus 2, 4, sp3. And 2 bond pairs and 2 lone pairs. What is the shape of the molecule? The shape of the molecule is angular, like water or bent structure. Angular shape. This is the, what it is not here, you know, chlorous acid. And the third one is what it is not here? Chloric acid. Clear? What is the chloric acid formula? Chloric acid. The chloric acid formula is HClO3. Clear? So how to write the structure? First of all, you know chlorine will form 1 bond, 3 bonds, 5 bonds and 7 bonds. Clear? So that's why. And here chlorine is there. First of all, what you have to do? You have to attach the OH. Clear? And there will be a double bond O. Clear? So how many oxygens are there? 3 oxygens are there. 2 we have used, and it's also used. Another oxygen should be written like this. If it is forming 5 bonds, then there it will have 1 lone pair. Clear? Why? Because you know what is the structure? 3s2, 3p5. 3s2 what is 1, 2, 3, 4 and 5 will have d orbitals also. Clear? 2 forming 5 bonds, and you know these 2 electrons should jump here. Total how many unpaired electrons we have? 5 unpaired electrons. When it is having 5 unpaired electrons, it will form, chlorine will form how many bonds here? 5 bonds. And that when it forms 5 bonds, it will have 1 lone pair. That is clear what it is? So that is, it will have 1 lone pair. So that's why, what is the shape here? This is clear. So in this case, what is the hybridization of chlorine? You check it. What is the hybridization? You see? And chlorine forms how many bonds here? 3 sigma bonds. So there are 3 bond pairs. How many lone pairs are there? 1 lone pair. So what is the hybridization? sp3 hybridization. 3 bond pairs and 1 lone pair. What is the shape here? Pyramidal shape. What is the shape here? Pyramidal shape. This is chloric acid. And next one, perchloric acid. What it is here? Perchloric acid. What is the formula of perchloric acid? HClO4. Clear? HClO4 means, you know, whenever we write the oxo acid, we have to first attach the OH to the central atom, and there will be a 1 double bond. Now chlorine is, H is used and 2 oxygens are used, and how many oxygens are left here? Another 2 oxygens. So these two oxygens should be connected through double bonds here. Clear? No? So this is double bond. So chlorine is forming how many bonds here? 7 bonds. When chlorine is forming 7 bonds, will it have any lone pair? No, it won't have any lone pair because all are, you know, and the NS2 amplified means all electrons, single electrons only, then only it will form the 7 bonds. So what is the hybridization you see? And there are 4 bond pairs and 0 lone pair. What is the hybridization here? sp3. sp3 means what is the shape here? Tetrahedral. What is the shape here? Okay. So this is means if you see the what is the hybridization of halogen in oxoacid means sp3 only. In all cases you see in hypochlorous acid hybridization of halogen is sp3 and chlorous acid also sp3, chloric acid sp3 and also periodic acid hybridization is same but structures are different. Clear? Very important this is why because in the PU examination they are asking and here write the structure of HClO3 or HClO4 perchloric acid or chloric acid structure for 1 mark they are asking in the PU examination only. So that's why you have to practice these structures. So next one is acidic strength of oxoacids. Clear? So if we discuss about the hypochlorous acid, what is the acidic strength? Clear? So acidic strength if you take, and first I will write here HOF. Clear? But you know this molecule is very unstable. Clear? Hypochlorous acid. You know I already mentioned fluorine forms only one oxo acid, that is the hypochlorous acid, which is very unstable. Clear? So that's why we won't discuss much about this hypochlorous acid. If you write here HOCl, clear? And HOBr, hypochlorous acid, hypobromous acid, and hypoiodide. Clear? So this is totally we have chlorous, hypochlorous, hypobromous, hypoiodous. Clear? Acids. Now, what is the acidic strength of this molecule? Clear? So what is the R of acidic strength? Clear? R of acidity, if you see, you know that all are having hydrogen here. If hydrogens it has, you know, they can release the H plus ions. So if it gives the H, any molecule gives the H plus ions, and those molecules we will consider as a acid. But all are having hydrogens here. Those are also attached to highly electronegative atom. So that's why, you know, these all are acids only. But you have to identify which one is more acidic. Which one is more acidic? Clear? So if you see in this case, the first case, and here H and O and Cl. Clear? You know that. And in this case, hydrogen is highly electronegative than the oxygen is highly electronegative than the hydrogen. So that's why it attract the electrons towards it. But you know here what is there? Chlorine. Chlorine and oxygen, which one is more electronegative? You know, chlorine, oxygen. Oxygen is only more electronegative. But compared to here, bromine and iodine, chlorine is somewhat more electronegative than the bromine and iodine. So that's why what it will do, it will try to pull the electron from the which one? Oxygen. It will try to pull the electrons from the oxygen. So when it is try to pull the electron from the oxygen, on the oxygen electron density will be somewhat less. When oxygen having electron density less, it immediately take the electrons from the hydrogen. So immediately it will take the electron from the hydrogen, means it releases the H plus ions very fast. Clear, my friends? So in the same, like if you take here chlorine, it is more electronegative than the bromine and then iodine. So that's why. So with it is depends upon acidic strength here depends upon the what is here electronegativity of the halogen atom. As the electronegativity increases, acidic strength of this hypochlorous acids also increases. Clear? So that's why what is the order here? You know, HO, Br, and what it is HO. This is the acidic strength. Why? Because you know, just simple. If oxygen is having more electron density, it won't take the electrons from the hydrogen easily. It won't take electrons from the hydrogen because it is electron rich already. If it is electron deficient, then immediately it will take the electron from the hydrogen and releases the H plus ions very fast. So that's why. And here compare chlorine, bromine and iodine. Chlorine is more electronegative. So in this compound, compared to the remaining two, the electron density on the oxygen is somewhat less. When oxygen electron density is low, then it will immediately take the electron from which one? Hydrogen, and it releases the H plus ions. But these two, after chlorine, bromine is more electronegative, so that's why compared to here, HOI, HOBr is more acidic. Clear? So this is about the acidic adder of hypochlorous acids. Clear? So means what it is here? In this case, acidic strength or acidic order is directly proportional to electronegativity of halogen. Means, and the hypochlorous of different halogens, and what is the acidic strength here? It depends upon the electronegativity. And second one, if I take, suppose I will take this is HClO4 and HCl means oxyacids of the same element, HClO3 and HClO2 and HOCl. In this case, what happens? What is the acidic strength here? You know that in this one means oxyacids of the same element. The acidic strength depend upon. Now here not the electronegativity. Why? Because in all cases what it is there? Chlorine only. Chlorine means it is having same electronegativity. So in this case you have to see the oxidation number. You have to see the which one? Oxidation number. So if you see here oxidation number is +7 and here +5 and here +3 and here +1. As the oxidation number increases, acidic strength also increases. So that's why here acidic strength directly proportional to which one? Oxidation state of halogen. Or you can say in another way also. What is that another way? You can write here. You know the previous we have in the organic we have discussed. Acidic strength of any acid, it depends upon the stability of its anion. After removing the H plus ion, so how much stable that anion? If the anion is very very stable, then the compound is more acidic. Same I will write here. And you know what is the structure here? OH is there. I will remove here. Then H, and this is the anion. For that, hypo means perchloric acid. This is anion. Means chloric acid. What is the anion here? Cl, O minus. There is a double bond O, and there is a double bond O. And next one is O minus. There is only double bond O. And next one is, and O minus, and there is no double bond. If you see in this one, which one is most stable among these three? This is why, because the negative charge and here single bond and here what are double bonds, means it is in conjugation. When it is in conjugation, they are involved in the resonance. Resonance with how many double bonds here? 3 double bonds, means you will get the 3 structures here. Clear? 3 resonant structure. Here 2 resonant structures. Here 1 resonant structure, and there is no resonant structure here. As the number of resonant structures increases, stability also increases. Which one is most stable here? This is most stable. So that's why. And this is the strongest acid. This is the what it is here? Strongest acid. Clear? So this is about the acidic strength. Next one, oxidizing properties. Clear? So oxidizing properties. If you see here, oxidizing properties. Clear? So means hypochlorous acids, they act as a powerful oxidizing agents. Clear? So oxidizing agents means what it has to do? It has to provide the oxygens to other substances. Clear? So all are having, if you see this one, in this case, this is HClO4 and HClO3, HClO2 and HClO. So which one is most stable here? This is most stable. It most stable means it won't break. This molecule will not decompose, will not break to give the hydrogens easily. But this is unstable. Unstable means what will happen? This bond breaks easily. So that's why it can provide the high oxygens easily to other substance. It can provide the oxygen easily to other substance means it is a powerful oxidizing agent compared to the red. Clear? So what is the stability order of these anions? This is the stability order. This is which order come here? Stability order. This is stability order. So which one is most stable? And this is perchloric acid anion is most stable compared to this. So that's why. What is the oxidizing power here? HClO3 is powerful oxidizing agent than the HClO2 and HClO3, and what it is? HCl. So this is about the oxidizing power. And if you take the among the hypochlorous acids if you take HOCl, you know, HOBr and HOI. In this case, what will happen? You see, clear? No? You know that. And this is HOF is, you know, very unstable. I will not talk about this. But if you see in among these three molecules, which one is the stable, you have to find. Which one is unstable? That act as a powerful oxidizing agent. Why? Because it is unstable, it breaks the halogen and oxygen bond and it can give the oxygens to other substance very easily. So that's why if you see here, oxygen and chlorine almost, they have almost electronegativity difference is almost zero. Means the difference between the electronegativity of oxygen and chlorine is very small. So that's why it is a strong covalent bond. It is a which one? Covalent bond. But if you are going from the hypochlorous acid to hypoiodous acid, here oxygen, the bond is what? Oxygen and iodine. So you know that here electron difference is more. If electron difference is more and polarity will be more, if polarity will be more, means it is covalent with ionic character. So ionic character means you already know it is strong compared to the covalent. So that's why you know stability order. If you see what is the order here, stability order of these compounds. If you see, this is the most stable. Clear? No? It is less stable, least stable. Least stable means what is the oxidizing order? Oxidizing. Clear? No? Oxidizing power means oxidizing agent. Oxidizing power order will be reverse. What it is not here? HOCl is greater than, HOBr is greater than, you know, HOI. This is about the acidic and oxidizing properties of hypo means oxidizing properties of, you know, oxoacids of halogens. So next concept here is interhalogen compounds. Clear? So what are interhalogen compounds? Previous we have already discussed about the interhalogen compounds. There I said we will discuss very depth in the means next video I mentioned there. So that's why here we got interhalogen compounds. Clear? So what are interhalogen compounds means? Halogens react with each other and forms a number of compounds called as interhalogen compounds. Clear? Halogens, they combine each other. Clear? And they react with each other and forms number of compounds called as a interhalogen compounds. Write that statement. And halogens react with each other. Halogens react with each other. Forms number of compounds called what it is here? Interhalogen compounds. Clear? So this is clear. So what is the general formula of interhalogen compounds? Clear? So the general formula of interhalogen compounds is what it is here? General formula of interhalogen compounds is XX-N. What is it here? XX-N. Clear? What is the X means here? X is equal to, this is X is equal to, you know, less electronegative element. Or you can say large size of halogen. Large size of which one here? Halogen. Means X should be large size halogen and X dash should be small size halogen. Clear? So what is the X dash here? More electronegative element or halogen. More electronegative halogen. Clear, no? You can write here more electronegative halogen. Clear, no? Or you can write here small size of, what it is not here, small size of halogen. This is what it is not, small size of halogen. Okay. So now, how many types of interhalogen compounds we have? Yeah, we have mainly 4 type of interhalogen compounds. I have already discussed previous XX- and XX-3 and XX-5 and XX-7. Clear? So now, what are the names of this compound? How to build nomenclature? You can simply say. Clear? So, what the nomenclature means? The name of these interhalogen compounds are halogen halides. Halogen halides. Why it is halogen halides? Because you know that this is halogen. This is simply, you know, I will take one example here. This X is a, you know, large size halogen. I will write here chlorine, and X dash should be small size halogen. I will write here chlorine. This is interhalogen compound. So chlorine and fluorine, which one is more electronegative? Fluorine. So that's why, and electrons moves towards the fluorine. So that's why fluorine gets with charge, negative charge. Whenever it gets negative charge, you know what we will call? This is fluoride. That's why. And this is named, we will simply call chlorine, and this is fluoride. So that's why halogen, chlorine, fluoride. That is halogen halide. That is the nomenclature. Clear? So that is name here. Now, which type? I mentioned, I will write here examples for this XX dash. You know what are the example? Here I will write example table like you write, and XX-3, and you know XX-5 and XX-7. Examples you write, then you will get the some clarity here. So what are the examples means here? Examples for XX-, Cl, F, Br, F, I, F. Shall I write here FCl? We should not write. Why? Because and first element should be large in size. First halogen should be large in size, and second halogen should be small in size. But fluorine, if I write FCl, fluorine is small size and chlorine is larger size. So you should not write like this. Always, and you know, large size halogen should be written first and followed by small size. So that's why ClF, BrF, and IF. I can write here Br, Cl, I, Cl. These all are examples. So XX3, shall I write here ClF3 and Br F3 and I F3 and Br Cl. All these are examples. Bromine is large size, chlorine is. And next one XX-5 and ClF5, Br F5 and IF5. These are the examples. XX only one compound, that is IF7. Iodine only can form the, you know, your XX-7 type interhalogen. Why? Why? Because you know, and here 7 fluorine atoms should be attached to the iodine. If suppose if I write here chlorine ClF7, if I write here what ClF7, this compound will it exist? No, it won't. Why? Because chlorine is small in size. It has to hold how many fluorine atoms? 4 fluorine atoms. If size is small, then what will happen, you see, and fluorine atoms comes very close together, and there will be a lone pair of electrons here, repulsion, and molecule will be unstable. So that's why small molecule cannot hold the 7, you know, fluorine atoms. So that's why, and this cannot be existed. So you know, as we are moving from the fluorine to iodine, as the iodine size is, you know, very large in size, so it can easily hold the 7 fluorine atoms. That is the reason. And this is about what it is known here, interhalogens, and we will discuss about the preparations. First, put the heading here, preparation of interhalogen compounds. Clear? So how to prepare these interhalogen compounds? Clear? So these interhalogen compounds are prepared either by direct, you know, combination of halogen atoms, or you know, on the action of halogen on lower interhalogen compounds. Clear? So how we will prepare, and I will write here, then you can understand. Preparation. What it is not here? Preparation of interhalogen compounds. It is there above interhalogen compounds. So preparation. So how we can prepare? We can prepare directly. Directly means take one chlorine and another one halogen and another halogen and react, and you will get the interhalogen compound. Simple example. I will take here chlorine and take the fluorine in 1:1 ratio. One volume of chlorine and one volume of fluorine, and maintain here 473 Kelvin. Then you will get the 2 ClF. Clear? And if I take suppose same reaction, I will take here excess amount. What it is not here? Excess. So 3 moles I will take. Then what I will get here? I will get the ClF3. Clear? So just maintain here 573 Kelvin. Clear? In the same way, if I write here iodine plus bromine, or you can write here chlorine. So if you heat this, what you will get now? 2 ICl. Clear? In the same way, iodine plus 3Cl2, then what you will get now? You will get the compound is, I2 plus 3Cl2, you will get the ICl3. This is clear? Direct combination this is. Or otherwise, sometimes you can write here, so BF3, boron, BrF3. Clear? Treated this one with the fluorine. This is lower interhalogens, and treated with the halogen. Then what we will get? BrF5. This is direct halogen, means one halogen react with another halogen. Lower halogen. Suppose if I write here, ClF, and I will treat this one with the fluorine. Then what I will get now? ClF3. Lower interhalogen compounds when reacted with the halogens, you will also get the interhalogen, higher interhalogen compounds. So this is what is my here preparation. Anyway, you can write here IF5. You can write simply here IF5 plus what it is my F2. You will get IF7. Bromine, and plus you can take here Br. Whatever you can take IBr3. Clear? Plus Br2. Then what you will get? IBr5. Clear? So this is about the preparation of what it is here interhalogen compounds. So here preparations we have completed. How can we prepare the interhalogen compounds? By 2 methods. Directly reaction between the halogen atoms, and second one is interhalogen, means lower interhalogen compounds reacted with the halogen, and you will get the higher interhalogen compounds. Clear? So next one is here physical properties. Clear? So all interhalogen compounds are covalent molecules. Why? Because there will be a small difference between the electronegativity. Clear? So that's why, and these all are covalent molecules. Clear? And also all are diamagnetic in nature. They all are which one? Diamagnetic. Why diamagnetic? You already know that. In the ICl, if you take here ClF formation, how it will be formed? Here there is a chlorine 3s2, 3p5. This is one, and this is what I got chlorine. And what is fluorine? Fluorine, this is 3s2, and this is what is 3p5. And fluorine, if you take 2s2, 2p5, 2s2 what is 1, 2, 3, 4, 5. Clear? And you see these two electrons, they pair up and form a ClF bond. Is there any unpaired electrons in this molecule ClF? Chlorine itself has one unpaired electron. Chlorine itself has one unpaired electron. When they combine, and these two electrons, and combine together, so that's why in the ClF there will be no unpaired electrons. So that's why, and these are which one? Diamagnetic in nature. Important disease. So interhalogen compounds shows which type of nature, means diamagnetic nature. Clear? So that is, and these are volatile solids and liquids. Most of the interhalogen compounds are volatile solids and liquids at room temperature, but some exceptions are there, and those are available in gases. So what are those? ClF, Br, ClF3, and ClF5. Not Br. ClF5 is also what it is here liquid. IF7, not this is IF7. This is what it is those are gases. Remaining all are which one? Either the solids are in liquid state. And there, if you see the properties, physical properties, the physical properties of interhalogen compounds are intermediate between their constitute halogens. Clear? Except what it is, if you take melting and boiling points. Clear? So melting and boiling points are little bit higher than the and halogens. Why? Why? Because if I take chlorine, Cl and fluorine. Clear? And if you see this boiling and melting point, ClF will have little higher boiling point than the chlorine and fluorine. Actually, this means properties should be in the between the chlorine and fluorine, but melting except melting points what it is and they are little bit higher than the melting points of chlorine and boiling or melting points what that may be of chlorine and fluorine. Why? Because means it is little bit polar. It is a non-polar. It is what is not polar. Cl bond is a which bond here? Little bit polar. Polar means what it is not. So it will show the high melting and boiling points. So due to higher, melting and boiling points are little higher than the expected. So these are about what it is not here, physical properties. And so next one is chemical properties. Physical properties for chemical properties. In general, interhalogen compounds are more reactive than halogens. This is very important question for your PU examination also. Clear? So what it is here? Interhalogen compounds. Interhalogen compounds are more reactive than what it is here? Halogens. More reactive than halogens. Clear? Interhalogen compounds means what I can write here? X dash. Halogen means what I can write here? X2. Clear? So this is question they are asking in the PU examination. Why interhalogen compounds are more reactive than the halogens? This is due to, clear? This is because the XX bond, clear? Because clear? XX dash bond in interhalogens. Clear? Now what is bond here? XX dash bond in interhalogens is weaker. Weaker than XX bond means it is here halogen, here interhalogen bond in what is here halogens. This is very important. Clear? So why? Because means here interhalogen compounds are more reactive than the halogens. Because what is because of XX dash bond means interhalogen bond between the halogen and halogen in interhalogen is weaker than the XX bond. Means here what is the bond here? It is a halogens, chlorine and chlorine. This is what it is now. Electronegativity difference is very means almost zero. Electronegativity difference is zero. So it is a strong bond, pure covalent. But here what it is bond here. This XCl and F. Which one is more electronegative? Chlorine. So that's why this bond can easily break. So that's why this bond, because chlorine is more electronegative than the chlorine, so this bond pair electrons it attracts towards it, so that's why this bond can easily break. So that's why, and XX dash bond is weaker, the bond can easily break compared to the XX bond in halogens. So that's why interhalogen compounds involved in the reaction very fast. Clear? So if you take another one reaction here, hydrolysis. Clear? So next one is what it is here? Hydrolysis. Hydrolysis of interhalogen compounds. What is here? Hydrolysis. Hydrolysis of interhalogen compounds. Hydrolysis. You have to do the hydrolysis. Clear? So this is also important for the competitive examination. Clear? Interhalogen compounds. Okay. Suppose we have four types of interhalogen compounds: XX dash, XX dash 3, XX dash 5, XX dash 7. So we will discuss one by one. First of all, XX dash. Clear? So do the hydrolysis. Clear? So what the compounds you will get? Clear? You will get the compound here is HX dash plus HOX, hypochlorous acid. Clear? Simple. Take one example here. Chlorine and fluorine. This is one example. Halogen. Chlorine is a larger, halogen, smaller halogen. Do the hydrolysis. Clear? Simple. If hydrolysis means what? H plus and what is there here? OH minus. And if this bond breaks, so which one acquires the positive and which one acquires negative? And fluorine is more electronegative. Chlorine is positive and fluorine is negative. Negative positive bond, negative positive bond. Then what the compound you will get? You will get the compound is HF, that is over here. HF, this is X means what is F. And here HO, that is. Clear? So HF, hydrogen fluoride, and what is here? Hypochlorous acid. In the same way, this is the first one. And what is the second one here? X dash 3. Clear? So here X dash 3. Same here. Always hydrogen means if you do the hydrolysis, HF will be formed. HX dash will be formed always. But and here I will take 2 moles, then I will get the HX dash. How many moles? 3 moles, and you will get HXO, hypochlorous acid. Chlorous acid. So this is simple example I will take ClF3 plus 2H2. Then what we will get? H and F. HF 3 hydrogens and 3 fluorines. One hydrogen left here. That is HF. HCl. What it is there here? O2 is there. So that is HCl O2. Hypochlorous acid. Chlorous acid. This is what it is. Hypochlorous acid. This is hypochlorous acid. And this is what? Hypochlorous acid. This is chlorous acid. If you take here another one, X dash 5, third one what is one? X dash 5, and take 3 moles of water, then what you will get here? 5 moles of HX dash plus HX, you can write HXO3. Clear? No? Simple. And ClF5. Take any example, no problem. And 3H2O, then what the compound you will get? 5 moles of HF plus HClO3. What is the name of this compound? Chloric acid. What is this compound? Chloric acid. In the same way, last one what it is here? X-7. How many molecules I have to take here? 4 what molecule you take? Then what you will get now? 8 and 7 HX dash and plus HX. O4. Take here what it is now? I have 7 is there, and treat this one with the 4 moles of water, and you will get 7 moles of HF plus, and what you will get now? HiO4, periodic acid. This is what it is here, periodic acid. So these are about what is here, chemical reactions. So next one is structures of what is here, interhalogen compounds. Clear? So first one is XX dash ClF. Only 2 atoms are there, elements are there. So always it is what is the shape of this molecule here? Linear. Clear? What is the central atom here? Chlorine. Larger one we will consider as a central atom. Clear? Next one. If I take here XX dash 3, what is the shape you have to write? Clear? So bromine BrCl3 I have taken. What is the central atom here? Bromine. Bromine is forming how many bonds here? 3 bonds. Means it is how many electrons it will have. So 1, 2, 3, 4, 5. And next which atom will come? D atom. It is bromine is forming how many bonds? 3 bonds with the 3 chlorine atom. 3 bonds means here. How many bond pairs? 3 bond pairs. And how many lone pairs? 3 lone pairs. That is. So in this compound, central atom is having 3 bond pairs. And how many lone pairs? 2 lone pairs. What is the central atom? Hybridization. 5 means what it is? sp3d. Clear? No? sp3d. So what is the shape of this molecule here? And if you see the 5 means trigonal bipyramidal. What is the shape here? Trigonal bipyramidal. Trigonal bipyramidal. or we can say here T shape. What it is by here? T shape. R can also be called as a seesaw shape. What it is by here? Seesaw shape. And how it is means trigonal bipyramidal means, I will write in this way. This is triangle. This is which one? There is a triangle. This is triangle. Clear? You know, in this one there are 3 lone pairs. How many lone pairs are there? 2 lone pairs. This is one lone pair, and this is one lone pair. Clear? And now in this case, you see, this is central atom. What is the central atom we have here? Bromine. This is one lone pair. This is what it is, one lone pair. And here also there is one lone pair. And here there will be one chlorine. And the axial is there here. This is axial. This is chlorine and this is chlorine. Clear? What the shape you see? This is T shape. It is like T shape or not? That is T shape. Or you can see seesaw shape also. This is what it is here. X, X3. If I go for X, X dash 5, or you can take BRF5. Bromine is forming how many bonds? 5 bonds. 5 bonds means 5 bond pairs. And 5 bonds forms. How many lone pairs it will have? One lone pair. Total how much? 6. 6 means what it is now? sp3d2. sp3d2 and 5 bond pairs and 1 lone pair. What is the shape of the molecule here? The shape of molecule is here and square pyramidal. What it is now here? Square pyramidal. The shape of this molecule is square pyramidal. What is the square pyramidal? And this is square pyramidal. What is there here? Bromine. And here there are 4 bromines are attached here. There is a fluorines F, F and F and F. And here there will be a 1 lone pair, and here there will be another fluorine. Clear no? So square pyramidal. This is square pyramidal. Clear no? In the same way, what is the shape of X, X dash 7? What is this one? IF 7. So here is there how many bond pairs are there? All are bond pairs only. Is there any lone pair here? 0 lone pair. Total what is 7. What is the hybridization of iodine here? Hybridization is sp3d3. sp3d3 means what is not? Pentagonal bipyramidal. What is the shape here? Shape of this molecule is pentagonal. Pentagonal bipyramidal. Pentagonal what it is not? Bipyramidal. What is the shape of this pentagonal bipyramidal? You see? This is. So pentagonal. This is pentagonal. Clear no? Bipyramidal. Clear? So here what is iodine is there, and here fluorine atoms. How many fluorine atoms are there here? 5. 1, 2, 3, 4, and 5. And there will be a pyramid. Clear? So this is F and F. This is first one is linear, and another one is trigonal bipyramidal or T shape, and XX5 means square pyramidal, and the last one is pentagonal bipyramidal. Pentagonal what it is now? Bipyramidal. So these are the shapes of what is by here interhalogen compounds. So last one is here uses. Clear? And these compounds are interhalogen compounds are used as a mainly solvents, and it is very important. It is interhalogen compounds are used as a powerful fluorinating agents. Clear? ClF3 and BrF3 used for production of uranium hexafluoride. If uranium is there and treated with the ClF3, and it will be converted into ClF6, and this is higher, interhalogen is converted into lower interhalogen compound. So very important, powerful fluorinating agent. And this is about the 17th group. In the next we will start the 18th group techniques.